Okay, so here's the last example. We have two different vectors, and just looking at that, which direction, where's the resultant vector going to end up when the force is pulling on that hook? Where do you think? Bachman?
In the middle of the two vectors and slightly more towards D.
Oh, in the middle of the two vectors, maybe slightly, yeah, probably slightly more towards D. They are different sizes, but we would expect it probably to be in quadrant 1, a little bit up and to the right, but probably a shallow angle. Okay, so if those of you in pre-calculus, you could probably do this without my help. Caden, put your phone away. Okay, so what do we got to do? In order to get the resultant vector, we need the x and y component of each vector. Okay, so for what do we know? For vector c, okay, what do we know? We know that, what's our shortcut formulas? The force of vector c is equal to, and we could sketch the right triangle if we want to, but the force of vector c, so SOHCAHTOA, what's that? What section is this in? The shortcut formula is not on there. Okay, so you have to know your SOHCAHTOA, and there is something on forces. The sum of the forces. That's a good question. SOHCAHTOA is on one of the first 3 pages, I'm sure. Well, we're going to have trusses on page 5. Truss analysis, there's some information down there. And that's one of the things, it is kind of scattered. Probably is at page 4. We have static equilibriums. At the bottom of page 3. Where is trig? If you don't remember your SOHCAHTOA, trig is on page, well, they have the law of cosines on page 2. Do they not have SOHCAHTOA on here? And this is the 2018 formula sheet that I'm looking at. Before we take the tests, I will print out the 2021 formula sheet. But sometimes they do update. I don't see SOHCAHTOA anywhere. Does anybody? I mean, you got to know it for your math class. I don't see SOHCAHTOA anywhere. Anybody see it? I don't see it. Okay. Huh? I'll have to look at the new one. I think I downloaded the newest version when I put it on Google Classroom, but I had some old copies, because usually from the end of course exam, if you don't write on it, I save them, and that's what I throw up front. So, the force of, huh?
I found it.
You found it? Where is it? Let's with the geometry?
Yeah. Right triangle.
Huh?
Right triangle.
Oh, it's right there with right triangles in Pythagorean theorem. Okay, now, like I said, you can always go back to that, but it's going to be a lot easier. The force of C would be, the force of C is, the force of C, if we do the, we could go back to the trig, that would be fine. In this case, it probably makes sense to just go back to the trig ratio, right? So if we do the cosine of 60 degrees would be adjacent, which that would be the force of C in the x direction divided by hypotenuse, which is 300 pounds. All right, so we can go back to the right triangle. When we get into the truss calculations, we're always probably going to want to do the shortcut for this. You know, when they use the shortcut, you would, if you wrote it as a shortcut, we usually write this equal to that times that. So either way. So then, of course, to solve that, the force of vector C in the x direction will be, what, 300 times the cosine of 60. What do you get? 150. Okay, and the sine of 60, sine is opposite over hypotenuse, so that would be the force of vector C in the y direction divided by 300. So then the force of C in the y direction would be, what, 300 sine of 60. What does that come out to? 260. Give me another decimal point. Oh, it's 259.8. Not going to get real excited about rounding. 259.8. Okay. So, what about vector D? How do we get vector D? Help me out, guys. Anybody? Huh? Okay, well, the sine of 30 is equal to what? Oh, that is the shortcut, isn't it? Yeah. You want to write the shortcut down? We could do it with the shortcut on this one. The force of D in the y direction, right? Force of D, vector D in the y direction would be 400 sine of 30. That would be our shortcut. So whether you want to use the ratios or use the shortcut, when we get into truss calculations, you're going to want to use the shortcut to get the x, y components. So 400 sine of 30 is what, 200? And it would be negative. Okay, awesome. Okay, and it's got to be negative. So it's got to be negative because we know it's going down in the y direction. So the force, So the force of D in the x direction would be 400 cosine 30. And what's that? 346.4. Okay. So then, now is when we use our other formulas. the sum of the forces, we do the sum of the forces in the x direction. So what's our two forces in the x direction? We got 150 plus 346.4. So that's what? 496. Is that right? 496.4. And then the sum of the forces in the y direction. Let's add our two y's together. We got 259.8 minus 200. So the sum of those is what? 59.8. Okay. So then what we need to do is sketch the resultant vector. So our result, we're going 496.4 to the right. We're going up 59.8. And this would be our resultant vector then. Okay? So something like that. So now what we have, Now we have a right triangle there, where those sides are 59.8. Oh, I labeled that side wrong, didn't I? Those sides are 496.4 and 59.8. Okay. So to get the resultant magnitude, how are we going to find the hypotenuse? Which would be the resultant magnitude. How do you get the hypotenuse of a right triangle? Pythagorean theorem. So then we would do and the Pythagorean theorem would be what in this case? We're looking for the force of the resultant vector. So I'm just going to label this F subscript R for the resultant vector, which would be what? The square root of 496.4 squared plus 59.8 squared. And what does that come out to? Huh? 499.9. That probably would round to close to 500 pounds. Right? 499.9. I'd probably, at this point, round that off. We'd probably have a little rounding error in there. And then what? Let's see. And then what? Oh. What's the actual direction? We're also going to want to find this angle. So how do we find that angle? We can use any trig function we want because we know all three sides. Usually I use the tangent on it, but you wouldn't have to. The missing angle would be what? The inverse tangent of 59 opposite over adjacent. 59.8 over 496.4. In geometry, did you get to inverses yet to find angles? Don says yes. What did you get? 6.8 degrees. Okay. Is that bad? Not that bad. Okay. All right, so what do we got? We got some practice problems in it. Oh, let's clear this. It really kind of breaks it down into baby steps. And I guess the other thing we didn't do is describe the sense of the vector. But of course, the sense of the vector, we would say it's going up and to the right at a 6.8 degree angle. Okay, so this breaks it down in the, and you can pull this up on your screen. We could probably start working through some of this, but what's the magnitude of vector A? Think of it as a sketch. What's the magnitude? Yep, 5 newtons. It's, again, this is baby steps. We did a whole problem with that last one. What's given to us? What is the direction of the vector relative to the x-axis? Well, that's the sense. Sense is down and right. Okay? But what's the direction of the vector relative to the x-axis? What's that asking for? Auckland? 60 degrees. They're telling us this is a 30-degree angle. The angle we need to use when we solve problems is a 60-degree angle. Okay? 60 degrees, and we would say relative to the axis, it's 60 degrees clockwise. That's what they would be looking for. Okay, so then it says sketch vector A with its x and y components. Okay, so all we got to do is add the x and y components and then solve for them. And then here they're telling us a lot of times they do give you directions on how much precision to use for final answer. All right, so we all should be able to get those, right? Do we want to use SOHCAHTOA or we want to use a shortcut? You like shortcut? Makes it a lot easier. So, what's the shortcut formula? The force of vector A in the x direction will be what? It's the force of A times what? The cosine of the angle. So if we figure out what would that be, that would be 5 times the cosine of 5 cosine of 60. 5 cosine of 60, which is what, 2.5. Okay, so this would be 2.5, and in this case we're in newtons instead of pounds. We're metrics, we have metric forces this time. Force of A in the y direction. So what is that? Force of A times sine of 60. You got to use x-axis. Well, I didn't write that down, but that's 5 sine of 60. $4.3. And it would need to be a negative because it's going down. Okay? Well, it's almost too easy. Now what do we have? We don't even need to do any math. What's the magnitude of B? 5. What's the direction on this one? 60 degrees. And we would say counterclockwise from the negative x-axis, because this would be 60 and this would be our negative x-axis then, right? Now, what's the sense of B? Down and left. Okay? So sketch vector B with its x and y components. We already know the numbers. What would they be? It's the same triangle. Negative. The x is negative 2.5. The y is negative 4.3. Okay? Do we have to solve it really? No, it's the same triangle flipped over. Because what's happening with this? Okay? We're hanging a picture off of a nail, and it's making a 30-degree angle. Now, if we hang a picture, are we going to see the wire? No. Usually the wire's behind the frame, so really it's usually like back here. They drew it this way, right? They drew it that way so we could see it and look at Newton there. Okay? So draw a free body diagram of the nail, illustrating the x and y components, and actually that's basically it. What do we have? We've got, so what will we need to add? Free body diagram of the forces on the nail. Well, we got 5 newtons going down, right? We got 5 newtons going this way. Okay, there's the nail. Where's the So we got these two triangles that look like this. What other vector would be a part of the free body diagram? We're missing a vector. We have 2 vectors. And its force is acting on a nail. Yeah, we have a force on the nail. The nail's got to be pulling up or the picture fell off the wall. Okay? So it says calculate the x and y components of the resultant force. So what is the resultant force? What's the 2 x components? What do we have? Negative 2.5 plus 2.5. So that's 0. What's the y components? Negative 4.3 plus negative 4.3 is negative 8.6. So that's the result of just those 2. So that means the resultant vector, if we wanted to sketch that, the resultant vector is this, negative 8.6 going down. So what's the force on the nail? What's the nail doing? Yeah. 8.6 pushing up. Right? 8 points, I guess just 8.6 newtons. How much does the picture weigh? 8.6 newtons. Right? Okay, that one was kind of baby steps. What do we got? We got 11, we have baby steps through a hook, which we did that. That's just like the hook we did at the beginning, except they're both going up and to the right. So keep in mind, we're going to need this angle. What's this resultant angle here going to be? That's the angle we need. Because they gave us a y-axis angle, so we're going to need this angle here to be 75. Okay, just like the hook, try that one on your own. Just like the other hook, the picture frame, kind of baby step this, we've walked through a bunch. Let's see how we do with trying to get answers to that final one on your own. If you need help or need something explained one-on-one, call her, check with your neighbor. Basins is making sense? Somewhat. You're in geometry this year? Yeah. And I know you just started trig as well, so you missed a day of it in math class. So what do you got to do? You know, this is just like the one we did at the beginning from the notes yet from yesterday. Okay? So break it down. You're going to draw, you can draw each of these angles as separate triangles. The sketching vector G is the bigger one, right? So sometimes it helps to draw it as a separate vector. So there's vector G, and that's then a 75-degree angle, and we need to know the force of G in the x direction and the force of G in the y direction. What angle do you use? You're going to use a 75. Always use a reference angle, the x-axis. So break it down, and then vector H. Vector H is a little bit easier to visualize, but if you have vector H is 20 degrees, and you have multiple vectors, you can draw them separately. Force of, so of course we got, that's 100, and what's that, 50? Force of H in the x direction, force of H in the y direction. And you can use the shortcut that we copied from the notes. That makes it a lot cleaner. Or you can do your SOHCAHTOA and figure out the missing pieces. You'll see some vectors on the end of course exam, not on the state test. You'll see it on the national test. We got a lot to do between now and then. But we also have a fun, we get to break some things again too. We might, now that I'm looking at, you are not going to have to solve the entire truss. I'm probably going to shorten truss calculations. You're going to have to solve a vector, results, method of joints. We'll probably just kind of go through one together. I'm going to shorten it because you're not going to have a full truss on the test, I don't think. And it takes a good 2 weeks to go all the way through trusses. Stress strain probably a touch more important. And tomorrow, all we have is just a little bit more practice on this. So there's our 3-minute warning. And then conclusions. Don't worry about the conclusions. See if you can finish up through 15. Oh, time to stop recording for Sadie.